Hi, it's Jeff, and in this segment of our Learn CDK course, we're going to work on VPCs, Virtual Private Clouds. In almost every project, the first thing you're going to want is a secure VPC network to place resources in. Now, this is critical to protecting your infrastructure and giving you the tools to secure and manage your work. Setting up your VPC is one of the best examples of why we love the CDK. This isn't a high-value part of your work. Nobody really wants to spend time building routing tables, but it is a high-importance part. It's critical to professional infrastructure that this is done well. The CDK doesn't just expose the AWS resources for us to manage in code, it actually simplifies and abstracts away most of the heavy lifting, allowing us to really rapidly and clearly describe what we need, and let the smart defaults of the CDK take away the rest. Now, if the idea of relying on smart defaults worries you, I wouldn't let it. We'll get into this more in a future lesson on security, but the AWS security team is involved in the CDK project and reviews its output to ensure best practices are followed. Second, as an open source project with growing popularity, people who care about security details and use the CDK are examining it, contributing suggestions up the chain, and all this makes sure that not only are their stacks more secure, but yours are as well. Finally, you can always review the detailed resource output. So if you're in a high security environment, you can take a look and make sure that the resources being created have the correct settings for your obligations. Don't spend your time crafting resource by resource, use the shortcuts, and double check the output if you feel you need to. Now back to actually creating a VPC. Let's pick a fairly typical example that we can build on later.
Here's an app stack layout from a recommended secure PCI-compliant setup. This is kind of my default, the starting point when I'm architecting on AWS. I'm going to do courses later on this year on creating secure and compliant cloud stacks for things like PCI in payments, HIPAA in healthcare, and SOC 2 for any secure and audited systems. So ping me on Twitter if that's something you're interested in. Let's say we're launching a LAMP stack on EC2. Security is important. We don't want to deal with breaches, so we're using best practices to separate our layers. This network is a VPC, Virtual Private Cloud, segregated from the internet and controlled by you. For fault tolerance, we're going to have our VPC cross two availability zones. This way we can mirror our servers and data between two physical locations in AWS, and if one goes down, the other will happily keep chugging along, and our users will never notice. In each zone, we have 3 layers of network, one public for our load balancer. We could put Bastion servers there if we needed them, but that's a security anti-pattern now. Use Session Manager instead. One private for our app servers that can only be reached from the load balancer, and a final private layer for the database that in turn can only be reached from the app servers. So to gain access to the database, you need to breach 2 layers. This gives us fine-grained control. We can create firewall rules at the network level for the database layer and separate firewall rules and controls for the app layer. Let's look at this with the app and DB resources removed so we can see exactly what the network layout is. This looks simple. 1 VPC, 6 subnets, an internet gateway, and a NAT gateway in each availability zone. In practice, let me show you how this was done in CloudFormation. This is a real CloudFormation template for a VPC setup I did at a company recently. It's a very similar layout to the one that we just looked at. It has public subnets, private subnets, database subnets, and as we scroll through, you can just see how many resources this is. There are gateway attachments, routing tables, route table attachments. Everything is associated with each other. NAT gateways, EIPs, private route tables, NAT route tables, associations between them, public subnet to route association. All told, we have about 25 resources being created in a hand-coded template to achieve the 6 subnets and 1 VPC that we looked at just a second ago. This is about 500 lines of CloudFormation YAML template. We're going to go see how easy that is to build in the CDK and how maintainable it'll be afterward. Okay, here's a freshly initialized CDK project. I know that the network setup is something I'll probably reuse in the future, so let's organize it well. I'm going to create a directory for my library namespace, libawesome. And creating a folder for stacks and a folder for custom components. We'll get into the details of subclassing or wrapping components in a later lesson. In the stacks folder, let's create our stacks class. And we'll need our imports for the CDK and any custom components we make. Now we can create a new stack class from the base one and we can give that a new constructor. There we go. It doesn't do much yet. It's an empty stack. Back in the main TypeScript file for our project, though, we can instantiate this new stack and make sure that everything runs. All right, let's create our stack and assign it to a variable so that we can access any output resources. Now, one thing that I usually do is name my stacks with a project environment stack naming scheme. This ends up being used in CloudFormation so that you can easily tell the stacks and their components apart. This is handy when you're launching dev, stage, and prod environments for the same project in the same AWS account. You don't want to be wondering which piece belongs to which environment and accidentally delete the wrong thing. I usually use some command line values or context files to determine the environment instead of hard coding it like this. And since I'm a little OCD, let's satisfy that now. Now we can use the built-in templating of TypeScript to clean this up a little bit. Now all of our stacks are going to be named org-environment-stack name network. So this will be put in automatically, and we can easily change our environment and our org names later, making our code a little bit more readable and a little bit easier to reuse. We also have props that we need to pass into our stack. We see that it's unhappy here about this variable because it's an undefined one, and we need to set that up with the variables it's going to need. So let's create one quickly using what we have. I always pass those in so that they can be used in a similar way by any resources created by the stack. So now we have props. We can see that it's causing an error though. Let's check the red underline. Has no properties in common with type stack props. It's best to create custom property class for each stack so that you can clearly see what it requires. So let's go back to the stack class and add a prop for it. And here we're just defining the values that we expect to be passed in. And we'll tell it to use that in our constructor now. There we go, save it. If we go back over to our main file now, we can see that it is totally happy with the props that we're passing in. The values of our props object match the expected values of our props here. Now the error is gone. We have good value and type checking happening on our passed arguments. So let's drop into the terminal here. Let's make sure everything's saved. If we check our watch build here, we can see that it's happily building our TypeScript into JavaScript. And if we drop into just our normal terminal here, let's do a CDK ls. From the command line will show us what resources it sees. Awesome dev network. So that's the stack. There are no resources right now. If we did a CDK synth to actually create the CloudFormation templates, it would put some basic cloud CDK structures in it, but there would be no resources because we haven't built anything yet. So let's make it do something. First thing we're going to need to do is to install the construct library for the EC2 products, which is where the VPC lives. So we do our npm install AWS CDK AWS EC2. That should take a second. This error pops up for me once in a while. I need to check into my npm setup, and I'm able to get around it each time by just deleting the package lock file. This isn't optimal, but it's working for me right now. I'll dig into that this weekend when I get a chance. Okay, we've installed the package that we needed. Now in our network stack, let's require that EC2 set of resources, and let's create a member variable in the class for our VPC stack. That'll allow us to access it later after we instantiate the VPC. There we go. Now let's instantiate it in our constructor after we call the superconstructor. This dot VPC. We're passing in the current stack object as the owner, as the scope of this VPC object. So we're maintaining kind of our tree of responsibility there. And we're going to do the same thing that we did before to name it. And now we need to pass some props into it, which are going to be blank for now. We're not going to do anything to the VPC. We're going to let it get created with all defaults. I'm going to save that, see that we have no errors coming up in our compiling to JavaScript. And now if we drop over back to our main one, let's actually do a CDK synth and see what we get. You know what? This will actually be easier to see over here. If I type correctly. Okay, no problems. Look at all these resources. This is starting to look similar to what we looked at in the old one that I had built by hand before. When we do a CDK synth, this resource, okay, there's our VPC. Let's go look at it over here. In our cdk.out folder, that's where our JSON representation of the, our JSON output of the synth command goes. So this is the full CloudFormation template. Here's the list of resources we see right at the top. There's our VPC, and it has a set of defaults. Let's see. Without any parameters at all, we have the VPC construct, creating everything necessary for our VPC. And it, by default, does 2 public subnets, 2 private subnets. Here we see public subnet 1, public subnet 1 route table, public subnet 1 default route. Look at all of the different things that get created by default. Public subnet 2. By default, it'll create 2 public subnets, 2 private subnets, an internet gateway, and all of the NAT gateways and route tables and associations necessary. By default, the VPC construct that we used will use 3 availability zones, but there's a catch to that. We haven't specified what region we want to launch in yet, so the CDK is in what they call environment agnostic mode. Now, to be safe, they use this mode so that if you tried to run this in any region, it'll limit you to 2 availability zones. So if we were to launch this right now in AWS, we would see 2 availability zones, 2 public subnets, 2 private subnets, and all of the routing and pipelines needed to connect everything together. 2 availability zones by default, 3 if you specify a region. 1 line of CDK code. Let's go back and don't forget here. We have 1 line of functional CDK code. This one right here. And it just created 24 AWS resources. And this is why I'm in love with the CDK. This is maintainable. This is readable. This is neither maintainable nor readable. How many lines did it do? 456. Okay, now let's configure this network to match our needs from the slide we saw before and the layout we need. First, I want to configure our CIDR, or network block, used by the VPC. Configuring this and hard-coding it, or specifying it at least, lets me launch multiple VPCs in my AWS account without them conflicting, and gives me the ability to organize them well. For this one, for example, we'll use 10.1.0.0 for the VPC in dev environment, and perhaps if I was launching a prod one as well, I might use 10.10.0.0. I could use 10.30 for a different project, 10.50 for something else. I could use 20 for another project, 30 for another. It gives me a nice way to organize the networks within my account without ever losing track of which resources, which hosts, which IP blocks are assigned to anything. So I also want to specify how many availability zones we're going to span and default that to 2. So the first thing we need to do is add these to our props class. Now you can see a nice thing about using these props classes. If we go back to our main file, we'll see an error on the props again. And hovering over that shows we're missing 2 properties. That's one thing I love about these plugins for VS Code and the code completion. It's clearly saying that we're missing 2 of the properties. Right there, missing the following properties from type blah 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 stack props, CIDR, and max AZs. So let's add those into the props values here that we're passing. And the error is gone. Let's update the VPC construct to actually use those values. Let's pass them into the VPC we're building. And again here, the auto-completion is awesome. The fact that it knows that CIDR is an available option on the properties for the VPC and on the object that we've passed in to our constructor makes everything a lot quicker as you're typing. Now, so far, no major changes from the defaults, but next I need to reorganize the subnets as well. The default, as we talked about before, is for 1 public and 1 private per availability zone, but we're going to need a 3rd for the database. Let's go to the CDK documentation to see actually what kind of subnets we can define in our VPC. This is the documentation page for the EC2 component of CDK, and this is a subnet type enum defined within it so that it has member variables we can use. So we see here that it's split up into isolated, private, and public. Now these are pretty clear in their definition, but the main distinction is between private subnets that can talk out to the internet but can't be reached from the internet, which would be perfect for your app servers, and isolated subnets, which can't reach out to the internet at all. They're completely cut off from the public internet. That's perfect for your databases and anything that really needs to be way behind the scenes. Now, if we look back at our network diagram, we need 2 availability zones, one in each, and in each one of those availability zones, a public, a private, and an isolated. Let's go back to our code, and we can pass an array of subnets into our VPC construct to have those configured. So the array member is subnet configuration. It takes an array. I'll paste those in so you don't have to watch me screw it up and type it over and over. There we go. So we have our 3 different types of subnet defined here. And we've named them. You can name them each. We have a public, an app, and a database. And they are of type public, private, and isolated, just like we looked at before. Now, another option is if you want to control how the IP space is divided up, you can specify that as well, or it'll be done evenly between them. For instance, if we want lots of IP addresses in our app subnets, because maybe we're using Docker and we have many images or instances in there, and less IPs in our public and database subnets, we can specify that the app subnets are /24, which I can paste in here. That gets 256 IP addresses, and maybe the others are /28, which only get 16 addresses. This gives you some fine-grained control over how the IP address space is divided up between your subnets and availability zones if you need it. Now let's make sure that everything is saved. We're going to want to go run CDK synth and take a look at what's get built. Okay, so everything's happy. Everything's compiling to JavaScript fine. Let's see what's different about our resources. So we're going to do a CDK synth to compile this all into the CloudFormation template. There we go. Let's open it up here in the VS Code. And we can immediately see, there we go, 10.1.0.0 for our VPC. If we search, we can find our database subnets. And there it is, 10.1.3/28. This all is looking good. This is difficult to read, though, so I think we should actually launch it into AWS, and then we can take a look at it there. Look at all these resources. This is building out 30 different AWS resources right now from our very small amount of code that's super readable, super maintainable. Before we do our deploy, one of the things we need to do is tell CDK where we want to deploy it. We mentioned earlier that this is running in agnostic mode right now, so we actually need to tell it our environment, our account, and our region that we prefer. So I'm going to paste that in quickly. We talked earlier about how CDK is running in kind of an agnostic mode until we specify our region, because then it can know a little bit more about things. Now this env property is always a part of the root properties. This CDK stack props object always has that env object in it that takes an account and a region. So this is always how you specify your account and region to a stack, to a project, to a component, within CDK. So now that that's there, let's drop back over to our normal prompt. Oh, we're already there. And let's do our deploy. I have more than one profile, so I'm going to specify here on the command line which profile I'm going to use to deploy, and there we go. A few seconds later, we see it deploying. We see the first CloudFormation resources start to get built. They're in a status creating right now, create in progress. So let's grab a cappuccino and check back in a few minutes. Done. Look at that happy green checkbox. All the resources look create complete. Let's head over to the AWS web console and we can take a look at what was built there in the VPC pages. Here we are in the CloudFormation console. Make sure that you're in the right region for where you deployed your code. Otherwise, it looks pretty empty. Here we see our awesome dev network named VPC, create complete. So this is our stack. This is exactly a representation in CloudFormation of the stack class that we created. We can check everything out here, create complete, created time. And if we go check out the resources, we can see everything that it built. VPC, Internet Gateway, VPC Gateway Attachment, routes, route tables, subnets, subnets, route tables, subnets, subnets, route tables. A whole ton of different resources just got created. The most interesting part is probably going to be if we head over to our VPC page, we can see what got built out there. There's our VPC, awesome dev network, awesome dev VPC. See how it's named from stack to resource. If we go look over at the subnets, this is going to be awesome. Here we go, app subnet 1 and 2, database subnet 1 and 2, public subnet 1 and 2, all linked to our VPC, all showing our nice naming structure and listing how many IPs are available in each. This is fantastic. And if we click around in here, we're also going to see things like our internet gateways, all built out, our route tables, our NAT gateways, all the things that we don't care about that much but need to be there. Everything is built and ready to go. This looks done for now. The coolest thing is that with only a few lines of code here in the CDK, how many lines of code? From here to here, 20 lines of code with some nice formatting, we were able to describe and construct 30 AWS resources in a very secure, best practices manner for our new app stack. We've abstracted it enough that we can reuse it. If we go over here, look at this. We're able to reuse this network class anytime we want, any project we want. We can pass in configuration values to run it again in multiple environments. We could quickly copy this out to build out a prod, a dev, a staging one. This really shows how powerful the CDK is and how fast you can move, and how easy it will be to maintain your project. So the next few videos, we're going to build out our app stack by launching some EC2 instances, configuring them with our app, giving them a database to talk to, and setting up auto-scaling for them. Stick around.